Let's review how to graph some functions that you looked at back in Algebra 1 and Algebra 2. These are polynomial functions, they're just easier ones. So the first ones that we're going to look at are polynomials with degrees of 0. And remember, these functions have degrees of 0 because if I put an x there to the exponent of 0, there he is, x to the 0 is the same thing as 1. So having that x to the 0 there, you could have it there or not, it doesn't mean anything. So we're going to say that f of x equals 4. Okay, I don't like looking at that x to the 0, so I'm going to erase it. This is a constant function. It has a degree of 0, and that just means that every y value, no matter where you are, is going to be 4. So when x is 1, your y value will be 4. When x is 2, your y value will be 4. 3, 4, 4, 4, 5, 4. All right, and what that does is it forms this horizontal line at the y value 4. Similarly, g of x equals negative 2 is going to form a horizontal line at negative 2. Constant functions are horizontal lines. If you have a degree of 0, you have a horizontal line at whatever the function value is. Degree of 1, you spent so much time on these in Algebra 1. A degree of 1, right, there's your little exponent of 1 right there, is a linear function. And when you talked about graphing these in Algebra 1, you would say you start at the y-intercept, you let x be 0, and the y-intercept here is a negative 1, and then you move however the slope tells you to move. In this case, you're going to go up 2 over 3, up 2 over 3, down 2 over 3, down 2 over 3, and you have a line that goes up from left to right. It's the slope of 2/3 and a y-intercept at negative 1. For g of x, your y-intercept is 3. Your slope is negative, so it will be decreasing from left to right, and you're going to go down 2 over 1, down 2 over 1, down 2 over 1. So you get enough points until you're comfy, and then you connect them. You have a linear function with a slope of negative 2 and a y-intercept of 3. Then we got a little more complicated on you. We made the degree 2. This degree is 2 because that x has a degree of 1 and this one has a degree of 1, and when you multiply them together you get an x squared. Remember that the zeros of so the degree of 2 is a quadratic function. And there are a lot of things we know about quadratic functions. The zeros of a quadratic function are the values of x that make these factors equal 0. This is in factored form, so I can say that one of my zeros is negative 2, and one of my zeros is a negative 6. So I have a 0 right there, and I have a 0 right here. All right, halfway in between your zeros is your axis of symmetry. So remember, we envision that as a vertical dashed line there, halfway in between my zeros. So my axis of symmetry is x equals negative 4. Okay. And my vertex lies on that axis of symmetry. So to find my vertex, I'm going to plug negative 4 into my function and see what y value I get out. So I have half of negative 4 plus 2 is negative 2, and negative 4 plus 6 is positive 2. So half of negative 2 times 2 is half of negative 4, which is negative 2. You can check that math out, but that's my vertex right here. So now I have this quadratic. Goes through that 0, has a minimum value on my vertex right there, and then it goes through that other 0. And you spent a lot of time graphing those in Algebra 2. Those are polynomials that you already know how to graph: a degree of 0, degree of 1, degree of 2. So we're not going to spend a lot more time focusing on those. We're going to focus most of our efforts on degrees of 3 and higher.